The primary auditory cortex lies in the posterior half of the superior temporal gyrus and slightly incorporates the lateral sulcus. The primary auditory cortex is made up of Brodmann's areas 41 and 42, but also involve Brodmann's areas 44, 45, and 22, otherwise known as Broca's and Wernicke's areas. The primary purpose of the auditory cortex is to differentiate auditory objects and identify their location in space. Broca's area interacts with the flow of sensory information from the temporal cortex and transmits the info to the motor cortex, which controls the mouth. Wernicke's area is responsible for complex language, auditory processing, and production of fluent speech, that is, speech without hesitation. Additionally, the primary auditory cortex incorporates 4 language-related pathways: dorsally, the D1 pathway and D2 pathway, then ventrally, the V1 and V2 pathway. The 2 main neurotransmitters used in the primary auditory pathway are GABA and glutamate. GABA is a primary inhibitory neurotransmitter and can influence information processing and cortical plasticity. Glutamate is a primary excitatory neurotransmitter. Damage to any of these areas can cause irreversible deficiencies. Primary auditory cortex damage causes loss of awareness of sound and an inability to detect changes in pitch and language comprehension issues. Damage to the auditory cortex can also affect motor movements and signals. If the motor cortex and auditory cortex cannot communicate, the flow of information in the brain is disrupted. Damage to Wernicke's area can induce paraphasias, or errors producing specific words. The 2 types of paraphasias are semantic paraphasia and phonemic paraphasias. Damage to Broca's area can cause effects such as telegraphic speech, which is sentences spoken that do not fit standard structure. In conclusion, the primary auditory cortex is made up of a series of complex structures that enable someone to properly comprehend and produce speech, and damage to any of these areas mentioned can cause adverse effects in their proper function.